Why does anything exist? What was there from the very beginning? Total emptiness? Or did something exist out of necessity for all eternity? Could there have been a pivotal moment where nothing evolved into something? Why not complete emptiness? Total blank? Is reality eternal? If not, would it at some point surrender itself to eternal absence? Is total emptiness even possible? If reality is brought into existence, does it require an external driver to initiate its being? Is it conceivable that reality originates from itself? Is its creation natural or supernatural? And what's the purpose behind reality? Does it just exist for no reason? What lies at the very core of existence? What's behind the genesis of it all? Is our universe just one fragment of reality? Or is it everything that exists? What triggered the creation of our universe? Was it a random process? Is it an effect? A product of something more fundamental? What's the mechanism behind the universe generator? What does the realm that precedes our universe even look like? Why the sequence of events that led to the current state of the universe occurred? And why this specific sequence was chosen over any other possibility? Not only probing the existential why and how questions hold the key to our origin, but also reveals possible fates of our future. Reality could have been buried deep within eternal non-existence. Yet, against all odds, reality prevails. Why existence? Absolute nothingness. No matter, no energy, nothing physical, no laws of nature, no space, no time, nothing that could define reality, no room for any form of existence. The pure simplicity of nothingness holds a greater expectancy as the default state compared to existence itself. At the same time, it could be argued that the likelihood of something existing should be higher than total nothingness, since there are countless ways for something to exist, while there's only one way for its absence. The fact that we exist indicates the dominance of something over nothingness. Philosophical nothing is the absence of all things, hence non-existence. Sounds simple, yet it remains as a hard-to-define abstract concept. Something has to be there physically to be observed and explored. The absence of our own mind is an impossible experience. The most fundamental and minimal form of something exists in the extremely small scale of the vacuum known as Planck length, the smallest measurable length in physics, around 1/16th of a billionth of a trillionth of a trillionth of a meter. Vacuum means empty space, but it's far from being truly empty. At this incredibly small scale, vacuum becomes a complex and dynamic environment. At its minimal energy level, vacuum is very chaotic and has these extremely small energy variations, revealing themselves by producing pairs of particles and antiparticles that materialize spontaneously and destroy each other in an instant. These extremely short-lived entities are known as virtual particles. They have physical existence, but not stable physical presence, annihilating each other in pairs right after coming out of the vacuum. Energy variations and virtual particles are different manifestations of the same reality. They're also called quantum fluctuations. The term quantum means the smallest measurable unit. To imagine the size of these fluctuations, there are about 25,400 million billion atoms in a row across 1 inch of a solid material. Energy variations are around 10 trillion times smaller than a single atom. This represents the most fundamental aspect of reality and has this fascinating feature: it's unpredictable. These temporary fluctuations represent the inherent uncertainty, unpredictability, and randomness present in the microscopic scale of nature. This state of minimal energy is labeled as nothing within the scientific realm. This is as close as we can get to nothingness. This pre-existing state of almost something could have been the source from which the matter, space-time, our entire universe with 2 trillion galaxies has originated. The way these virtual particles manage to come out of the vacuum is extraordinary. Virtual particle pairs can pop into existence by temporarily borrowing energy from the vacuum, as long as they return to their initial state by annihilating each other in no longer than Planck time. About roughly 1/10 of a millionth of a trillionth of a trillionth of a trillionth of a second, the smallest meaningful unit of time. As an unavoidable statistical event, quantum fluctuations every now and then create remarkably large energy disturbances within the vacuum, causing it to transition from its lowest stable energy state to a temporary high energy unstable state called false vacuum. The vacuum is filled with various fields that can interact with matter and each other. Particles could be imagined as excitations of these fields, like electron field that spreads throughout space and gives rise to electrons when excited. Although quantum fluctuations or virtual particles are not directly observable and don't behave like ordinary particles, they can also be thought of as excitations within the vacuum. A hypothetical field known as inflaton is subject to energy fluctuations like any other field and has the potential to generate an extremely powerful anti-gravity force as a consequence of large energy variations. This drives the inflaton field into a false vacuum state, initiating a phenomenon known as cosmic inflation, causing space to expand exponentially. Due to its unstable nature, false vacuum starts losing energy and decays randomly in different regions of expanding space, forming microscopic space-time bubbles in decayed areas. The bubbles experience their own rapid expansion. Some don't make it through and dissipate quickly due to quantum fluctuations. However, on rare occasions, a small bubble can expand at a sufficient rate, eventually reaching a significant size. Our universe is in fact one of these surviving bubbles. The extremely negative or anti-gravity pressure triggers the expansion of the bubble from extremely small volume by at least a factor of 10 to the power of 78, 1 followed by 78 zeros. 1 million trillion 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 times larger in just a fraction of a second. The microscopic universe can be magnified to the scale of the observable universe, a mind-bendingly large sphere with a diameter of 93 billion light-years. Traveling across a sphere of this size from one edge to another at the speed of light, roughly 186,000 miles per second, would take 93 billion years. Less than a second was all it took for inflation to expand our universe to this volume. Inflation converts its potential energy into an enormous amount of matter and radiation in its decaying process. Every expanding bubble turns into an extremely hot Big Bang, one of which is our own. Due to a lower vacuum energy state, inflation in those regions slows down and stabilizes at a lower energy level, during which it shapes the space-time that composes those universes. The inflationary process eventually comes to a halt. The post-inflationary epoch is when the universe as we know it begins. the duration of time that passed during the inflationary epoch might not have been uniform across the entire universe, and the universe's expansion potentially impacted the flow of time. The mathematical description of inflation doesn't rely on a traditional concept of time. This doesn't mean that inflation brought the universe into existence without time. Rather, the understanding of time itself becomes different under these extreme conditions. Even the conventional notion of causality, with its fixed order of cause and effect, might not have been valid during this period. The energy variations present during the expansion were stretched and intensified along with universe's growth. The same energy fluctuations that we observe today in the afterglow of the Big Bang billions of years later. The rapid expansion of space during inflation flattened any initial irregularities in the universe. This is why the universe appears uniform in all directions on large scales today. Quantum fluctuations during inflation are thought to be responsible for the matter density variations we see today throughout the cosmos. Energy variations in the false vacuum and cosmic inflation laid the foundation for the galaxy formation and the complex structure of the universe. In extremely high energies and billions of degrees temperature, the universe was symmetrical, meaning the laws of physics and fundamental forces of nature were all unified. As the universe cooled down and expanded, certain symmetries were broken, leading to the development of diverse particles and phenomena we observe today. This phenomenon is referred to as symmetry breaking. A couple of billion years ago, during a point that marks roughly half of the universe's existence, dark energy, a mysterious form of energy that is thought to be spread throughout space, started to dominate the expansion. Before that, the expansion was primarily governed by the gravitational attraction of matter, which was gradually slowing down the expansion. Assuming our bubble universe has a closed shape with positive curvature, meaning its space is curved in a way that traveling in a straight line would eventually loop back to the starting point, the expansion could potentially slow down due to the gravitational attraction of matter. If the density of regular matter is high enough, the universe's expansion might eventually reverse, leading to bubble contraction. If this contraction continues, the universe will become denser and denser with higher pressure and temperature as it collapses. Eventually, everything in the universe could be compressed into an extremely hot and dense state, maybe similar to the conditions at the beginning of the Big Bang. The universe would eventually end in a big crunch. That's not the case for our universe. The influence of dark energy became more significant around 5 billion years ago, and it started to counteract the gravitational pull of matter, leading to the accelerated expansion of the universe that we observe today. Dark energy is the reason why all the galaxies in the universe today are moving away from each other, with the exception of the ones held tightly in gravitational bonds. The inherent randomness in the decaying process of inflation is thought to be independent of any known cause. The most extraordinary feature of inflation is that once it starts, it never stops. As it consistently decays in random regions, it gives rise to local Big Bangs, generating an infinite number of them as it continues for eternity. These Big Bangs happen independently and at different times. They're relatively rare and probabilistic phenomena, rather than a common occurrence. The universes that evolve out of those Big Bangs are causally disconnected from each other. So inflation, in its simplest form, is an eternal production of universes, giving rise to an infinite number of universes, hence the multiverse. The eternal inflationary process is guaranteed to produce alternate versions of our universe, starting from a different initial state of the Big Bang, resulting in totally different regions of space-time or universes. Assuming they're physically possible, those universes do exist somewhere in the multiverse. These self-contained realms are governed by their unique set of cosmic parameters. The bubbles possess a limited size at any specific point in time, yet some of them will continue expanding infinitely to reach exceedingly large sizes. When observed externally, a bubble universe appears as an expanding entity. From inside, it seems to stretch infinitely. The most straightforward and simplest approach, which is particularly appealing in scientific realm, is represented by the chaotic inflation model. This model permits universes to select their initial conditions from a wide range of values, leading to greater diversity in the types of universes that can emerge. This includes different particles, forces, diverse forms of matter and energy, distinct geometries, and maybe even number of spatial dimensions, key factors that influence the state of each universe. The majority of universes based on chaotic model are vastly different from our own. We are just one iteration in grand scheme of all multiple universes. Each of these realities bears a profound significance of its own. The physics we observe in our universe may seem random. In a multiverse, these observations could be just one option among a very large landscape of physically realizable possibilities. The number of different types of universes, according to a well-known calculation, is 10 to the power of 500, 1 with 500 zeros. By comparison, the estimated number of atoms in the observable universe is approximately 10 to the power of 80. This is how many types of universes can be produced by chaotic inflation, but the number of universes is infinite. For now, infinities are treated as abstract mathematical concepts and might sometimes lead to logical paradoxes. They may not have a direct representation in the physical realm. According to the most credible inflation models, it's improbable that inflation extended infinitely into the past, but it will continue eternally into the future. Chaotic inflation presents another fascinating consequence. Random localized zones within universes have the potential to experience their own inflationary phases, resulting in the generation of baby universes within the larger universe. Bubbles within bubbles. Our universe could have emerged from an arbitrary patch of space within a parent universe and undergone exponential growth. Arbitrary small patches of space within our universe might undergo their own individual false vacuum states and result in inflationary epochs, producing distinct bubble universes. Later in their evolution, these bubbles might contain further bubble universes, leading to a pattern of universes nested within universes, resembling a fractal structure. We don't witness the creation of these bubbles because they come out of rare energy fluctuations. Assuming a universe continues to exist for trillions of years, their occurrence is statistically guaranteed. It is possible to identify indications of bubble collisions in the afterglow of the Big Bang, the cosmic microwave background radiation map. The bubbles expand, yet collisions are rare as the space between them expands even faster due to inflation. And that's why traveling to other bubbles is not feasible, since their expansion speed approaches the speed of light. the fundamental physical properties of our universe appear to be precisely adjusted to support our existence. But why is that? Even the slightest alternations to some values would disrupt the whole balance. Dark energy, as a prime example, needed to be adjusted to the degree of 1 part in 1 trillion 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 to set the expansion of the universe the way it is after inflation. An unimaginable level of accuracy. If the value of dark energy was smaller, the universe would have collapsed due to overpowering gravitational forces pulling everything together. If it were bigger, the repulsive force would be too large to allow the formation of a universe like ours. Extremely fast expansion would have prevented galaxy formation, making life formation impossible. A rare event is more likely to happen over many tries than in just one attempt. This was the first indication that there really could be a ginormous multiverse out there. While concrete scientific evidence for the multiverse is lacking, this is how science tries to tackle not only the physical how, but also certain philosophical why questions. The amount of dark energy in our universe is fine-tuned for life, and the multiverse can tell us why. Our region in the multiverse is favorable for the existence of our kind of carbon-based life. In this specific context, our universe is extremely improbable, but within the framework of the multiverse, we just live in a bubble where the extremely small strength of dark energy permits the formation of cosmic structures and eventually life as we know it. With a multitude of varied conditions at play, we are guaranteed to exist within a universe that aligns with the conditions suitable for our form of life. Only universes that are suitable for life would be observed by conscious beings like us. An accuracy like 1 part in 10 to the power of 120 is mind-boggling. But at the same time, chaotic inflation produces a large variety of universes up to 10 to the power of 500. This decreases the rarity of a universe like ours coming into being. The multiverse is infinite. Universes that could be seen as extremely rare will ultimately materialize. The unstable nature of nothing is the driving force behind the phenomena we witness around us. Nothingness plays a clever game on its non-existence, turning into pairs of positive and negative existence that cancel each other out at zero, returning to nothingness again. But only on some rare occasions they become powerful enough to trigger a series of interconnected reactions, leading to the sudden emergence of universes. The state of absolute nothingness could be inherently and fundamentally impossible. No conscious being can ever experience a state of absolute nothingness. It's only natural to feel baffled when faced with concepts that contradict our past experiences. There's no empirical support for the notion that the non-existence of our universe is more natural than its existence. But assuming nothingness is a possibility, what made something overcome nothingness? What makes it superior? We don't know. In eternal inflation model, the vacuum, the state of minimal energy must be there from the very beginning. But where does the vacuum come from? There's one cosmic model that tries to address this problem. In this bizarre model, a bubble universe emerges out of pure potential, this time even in the absence of a vacuum or empty space. No space, no time, randomly, with no cause. Spontaneous creation out of nothing. Based on cosmic inflation model, high energy fluctuations in the quantum vacuum generate the bubble of space-time that expands and develops into a fresh universe. A fluctuated bubble universe starts with a minuscule size and high energy vacuum with anti-gravity force that drives the bubble inflation. If the radius of the bubble is too small, it would collapse back into nothingness due to gravitational collapse, or stay in a low energy state. But if it's big enough, the vacuum's repulsive force will dominate and universe will go through inflation, experiencing rapid exponential growth and becoming enormous in size. So for the small radius universe to avoid collapsing, it has to turn into a larger sized bubble. At the core of quantum creation lies a strange behavior by elementary particles. They can end up in a spot without traveling through the space in between, a phenomenon known as quantum tunneling. Sounds impossible, but this is part of everyday reality. This, in fact, is what contributes to the nuclear fusion happening in the sun's core. A tiny universe can potentially tunnel from a small to a large-sized bubble. In the creation out of nothing model, the high-energy vacuum aligns with the small size of the universe. What's fascinating is that mathematically, altering the initial bubble radius to 0 doesn't diminish the tunneling probability. Several factors come into play in determining the likelihood of quantum tunneling of this sort. The common probability is 1 in 10,000 trillion. No matter how unlikely it seems, genesis out of nothing is an inevitable statistical probability. Different probabilities are assigned to the emergence of bubbles in various sizes and different types of high-energy vacuums. But the highest probability is applied to the largest energy vacuum and the smallest initial size. And interestingly, the most straightforward mathematical description arises when a universe initiates from an initial size of 0. Universes tunnel from no space-time, spontaneously out of nothing. Once initiated, bubbles grow to a finite size and undergo inflation. A universe originates with no space-time, transitioning from nothingness into existence. This form of creation is also an unpredictable and spontaneous quantum phenomenon with no clear cause. And although it's called creation out of nothing, it still requires something special. The quantum mechanical laws need to be there from the very beginning. We tend to assign cause and effect within a universe, but those laws don't necessarily apply to the origin of a universe. This uncaused phenomenon unfolds randomly, inevitably giving rise to a multiverse. Our universe could be one of countless bubbles emerged from nothing with life-enabling conditions. But how can a universe come into existence in the absence of time? Would it even make sense to ask about timing of such an event, since it came out of nothing? It could be that time in this context comes into existence alongside the universe itself. Time here is regarded as a measurement of change. If there was initially nothing, and then something suddenly came into existence, it could be argued that time began at that very moment as a requirement for measuring change. The contrasting perspective is that time exists autonomously from any physical mechanism and is not limited to the physical world. This would indicate that time was present prior to any physical processes, and the idea of prior to the Big Bang might not necessarily be limited to the conventional linear progression of time as we perceive it. The initial something that came into existence marked the start of physical processes, but not the beginning of time. Imagine a cosmos that only contains motionless particles and nothing else. Initially, things remain unchanged, except for the fact that the particles gradually fade away in an unpredictable manner according to known physics. Remarkably, even after all the particles have completely disappeared, time could still persist, because the emergence of new particles tunneling out of nothing would be an unavoidable phenomenon. Time in this case progresses due to the potential for changes to occur. Until there's a method to experimentally verify the proposition, tunneling out of nothing will continue to be a speculation. As other universes remain beyond our observational reach, there might be a particular way of directly detecting a bubble that has tunneled into existence. Within a pre-existing universe, certain bubbles may form as a result of chaotic inflation, but not expand sufficiently to become separate universes. Instead, these bubbles stop expanding and undergo a transition into a phase of inward collapse, ultimately turning into black holes. What separates these black holes from other types is their specific mass distribution. If black holes with this expected mass were detected, it might provide proof in favor of a multiverse and validate this phase of bubble nucleation. These particular black holes could also provide an explanation for the genesis of the supermassive black holes at the cores of galaxies. If these black holes are really out there, they're essentially universes that emerge from nothing, tried to expand, but ultimately fell short in growing larger. Both chaotic inflation and tunneling out of nothing proposals produce countless universes, but the mathematics behind them and the details of their predictions are different. Both models are attempts to explain the observed cosmological features. A universe can either be open or closed. Universes that tunnel into existence from nothing must have a space-time that's closed on itself, like a sphere, because an open universe is infinite in size, and the chances of an infinite quantum fluctuation is virtually impossible. Although bubble formations are random in certain values, they all follow the same fundamental principles. Within a closed universe, the net energy adds up to zero, which sounds crazy, considering the vast quantity of matter and radiation in the universe. The positive generation of matter is counteracted by its negative gravitational energy, sums up to zero, and remains constant over time. Interestingly enough, our universe also has this feature. Gravitational negative energy cancels out the positive energy of matter and other sources, resulting in zero. While the energy can be transformed from one form to another, the total energy remains constant. The total energy of all stars and galaxies is an enormous amount of energy, which is cancelled exactly by the negative contribution of the gravity that exists throughout the universe, and ultimately adds up to zero. Virtual particle pairs within a closed universe borrow energy from the vacuum and pop into existence spontaneously, but then have to disappear quickly due to energy conservation law. These conserved quantities, with their remarkable property of summing up to zero, contribute to the balance and equilibrium of the universe. In any interaction or process, the sum of positive and negative charges always balances out and ends up in zero. So the energy in this type of universe is conserved. Our observable universe, which extends around 46 billion light-years in all directions, is almost flat. The geometry of the entire universe, meaning both its observable and unobservable domains, based on its zero energy feature, could be closed. Maybe the reason we measure a flat universe is because we see only a small part of it that appears flat. Just like how we don't typically perceive Earth's curvature in our everyday experience, because the planet is so large compared to our immediate surrounding. The fascinating fact is that a non-existent universe has the same energy as an existing closed universe, one in which time has a beginning. If the laws of physics incorporate conservation laws, a universe following those laws might ultimately begin and end in a state of nothingness. In this scenario, the universe could be perceived as a strange version of nothing. Without the energy conservation law, the universe would exist in a vastly different state compared to its current form. An entire multiverse containing entirely separate universes could also remain consistent with the principle of energy conservation, as the gravitational negative energy that holds each universe together offsets all the energy contained within its material particles or its positive energy. For the tunneling from nothing model to function, the laws of physics must exist independently of the fluctuating universe. But how the quantum laws are there independently right from the beginning? Where do they come from? And what decides which laws they should be? To address this, we need to elevate our perspective to a higher level, embracing an even more diverse multiverse, the ultimate and the most radical of all multiverse hypotheses, which, contrary to expectations, leads to a simpler understanding of existence, the mathematical universe hypothesis. There's something that's even more fundamental, or in a sense, more ancient than the quantum laws themselves, and that's mathematics. Mathematical facts don't depend on anything physical, like 2 + 2 = 4, a statement that is true by definition and rules of logic. These eternal and unchanging facts are true in all conceivable worlds. Logical truths, like the fact that a contradiction cannot represent reality, are considered to be independent of the physical world. The fact 2 + 2 = 4 is true regardless of whether there are any physical objects that can be added together. Physical reality is a mathematical construct, a pure mathematical form unaffected by real-world objects. Even the attributes of empty space, like quantum fluctuations, are mathematical in nature. Mathematics describes the universe so good, simply because the universe is mathematical at its core. If this is true, then all mathematically conceivable configurations could be out there, all objectively real. Each of these forms can be perceived as an independent universe. Every universe at this level is a manifestation of certain mathematical truths. The mathematical form that our universe is a part of would be just one among countless possible forms. Each of these structures could potentially give rise to its own set of universes. The entire set of universes produced by cosmic inflation lie under one of these mathematical forms, governed by a specific set of mathematical principles. In such a system, there could be a form that produces physical universes with laws vastly different from quantum mechanics. The combination of these forms, making the ultimate multiverse, is by itself a mathematical structure. We have zero insight into what that form is, and may never succeed in uncovering it. As we transition from the comprehensive view of literally everything at the highest level, down to, let's say, a single universe like ours, the simplicity and symmetry go away. The uppermost level of the multiverse is characterized by its simplicity, as it includes every conceivable logical possibility. It's simple, balanced, symmetric, and easy to describe, the sum of all logical possibilities. As we widen our perspective to perceive the entirety of the mathematical multiverse, there's no more questions to ask, like why these parameters, why this set of laws, why quantum, why vacuum fluctuations, or ultimately why this set of mathematical equations. If all the possible worlds are not out there, there could be a mechanism that selects specific ones to come into existence while preventing others. Such a mechanism disrupts the symmetry and simplicity of the whole picture. The simplest explanation with fewer assumptions is generally preferred in both science and philosophy. At this stage of the multiverse, there's no necessity to specify anything whatsoever. These mathematical forms are not universes that are brought into existence or have a physical presence somewhere. They just exist. They're mathematical truths that remain unaffected by anything. Nothing in this level of existence is contingent or caused by something. Everything that exists is necessary and independent. Nothing has a cause. Things exist not by chance or accident, but by necessity. The fact that these entities give rise to physical realities is astonishing. The mathematical abstract world manifests and controls the physical realities, but the mechanics of this influence is a great mystery. Mathematical forms are eternal, abstract, fixed, and unchanging entities that exist independently of space-time. Think of a storage device containing a movie. The movie progresses, but the device remains unchanged. Abstract entities like integers or the laws of logic are timeless. They exist independently of human cognition, without any origin or creation. They don't need to be created, because they are the reality. They predate everything, including physical existence. Chaotic inflationary multiverse is a unified structure, containing regions or universes with varying conditions. In contrast, the mathematical multiverse comprises entirely separate realities isolated from each other, not originating from a shared history, and not necessarily governed by identical physical laws. Not all mathematical descriptions are linked to the material world. Physical realities manifest just through some mathematical configurations. Some realities could be too abstract to be manifested as physical entities. Certain mathematical structures might be entirely devoid of any physical universe, or with physical existence but without any observers. There are no ultimate physical laws. Rather, there are all possible combinations of laws, each giving rise to its own array of universes. If this multiverse is really out there, it's the final and the ultimate multiverse. As this multiverse includes every conceivable variation of realities, if this doesn't mark the end of the multiverse hierarchy, then maybe there's something beyond mathematics that is so alien to us that we can't even begin to comprehend. Events happening within a universe of this type have zero causal relationship with the events in other universes. The non-existence of causal links makes this level of multiverse hopelessly unscientific. Theories proposing an eternal existence fail to provide an explanation for the presence of reality itself rather than absolute emptiness. Many believe that reality doesn't have the privilege to exist independently. Maybe reality simply exists with no explanation for its origin. Maybe its existence is deemed necessary, something that simply is the case, with no further reason, something that can't be explained by any other fact or principle, resistant to further reduction or explanation, something that simply is a given, a self-existing and eternal entity, a cause that has no origin or preceding influence, something that is self-created through sheer will, a brute fact with no explanation, something that inherently can't be non-existent. To describe something as necessary and universal means it applies in all situations. Truth is considered necessary if it remains valid in every conceivable scenario or possible world. Multiverse seems the best explanation for something that appears to require no explanation in the first place. The alternative answer could be an essential creative cause, an intelligent force often associated with the concept of God, a fundamental and eternal mind that justifies its own existence without external causes, responsible for the creation of everything. The Creator needs no cause and holds qualities of eternal existence and autonomy. By definition, God couldn't have been created by anything outside of itself. This supreme force picked our universe from an array of potential choices, perhaps selecting the simplest and the most elegant configuration. If the universe was created by God, then either it chose our universe with its life-sustaining attributes, or it designed an entire multiverse. Maybe God didn't create reality, but rather, it is in fact the only reality. God in this case is an infinite mind, containing all the patterns of entities and occurrences, including the patterns of countless universes. The universe is synonymous with God, and all that exists is an integral component of its being. The divine consciousness continuously engages in self-exploration through its own existence. Existence is solely a product of divine thinking. Consciousness in this case could be a fundamental aspect of reality. This, of course, is an unfalsifiable hypothesis that lacks empirical support. The concept of God doesn't provide the more compelling response to the question, why is there anything? If we assume that a self-explanatory supreme being can provide explanations for all the phenomena we observe, then why couldn't the entire reality be also explained by itself? The opposing view argues that science reduces the need for invoking God's intervention to explain the workings of the universe. There's no need for a God to initiate the universe. So the inherent challenge about God lies in the absence of a fundamental distinction between the notion of an eternally existing God and an eternally existing reality devoid of God. The sequence of causation originates from God, and He validates His own presence. But this raises the question of why the universe itself couldn't adopt the same self-explanatory approach. Why can't we just use the word universe instead of God? So it might be unnecessary to propose a creator or emphasize its necessity, unless there's empirical evidence verifying its presence. Regardless of how extensively we explore the genesis of reality, even if we define something as the initial cause, we are still confronted with the origin dilemma. From where did that originate? Trying to prove the existence of a perfect supreme being through logic and philosophy alone, rather than observation or experience, doesn't seem to be the right approach. In a chaotic inflation picture, universes give birth to new baby universes in a never-ending cycle of cosmic creation. The existence of a prior universe for every presently existing one forms an infinite chain of universes. Each universe is linked to the one before, leading to a complete explanation of the entire chain. From this perspective, the idea that each link in the chain has its own explanation eliminates the necessity to explain the chain in its entirety. The infinite chain just lies there. It simply exists, and that could be the answer to why the cosmos exists. In the absence of an initial cause, whether by God, inflation, or something else, to what point does the sequence of causes and effects trace back? Inflation or any mechanism generating universes might have extended infinitely into the past. But is this even logically coherent? What if that's not the case? If it's not, where's the origin, the source, the initial point? There's a solution to escape this problem. A cosmic model that claims the universe is a self-sufficient entity that has the inherent capacity to account for its own origin and continued existence. Reality in this model doesn't require an external force to bring it into existence, and doesn't have an infinite chain of cause and effects, as it has an explanation embedded within its own nature. Existence, according to this model, creates itself. The entirety of the chain, taken together, is not influenced or caused by anything. But how is it possible for something to cause itself? Sounds impossible, but as the model suggests, Einstein's equations enable the universe to self-generate. So maybe the universe is made out of something, and that something is itself. For something to create itself, it must already exist to initiate the process, and that would suggest that it had already been created. Hence, it couldn't have created itself. So how could the universe produce itself? The answer is time travel. There's a specific type of geometry in Albert Einstein's equations that provides solutions for traveling back in time and addressing the first cause problem. As an object progresses through time, its paths remain intact, similar to how its initial location remains while it moves away from it. Space-time is flexible and can be bent into various forms. In Einstein's equations, solutions related to time travel point to highly curved structures called closed time-like curves. These structures enable the possibility for a time traveler to look back and revisit an event from their own past. The Worldline's path is always towards the future, yet it loops back to revisit the past. Just like how observers travel the curved surface of the Earth in a straight path, eventually return to their initial point of departure. But how is this related to the concept of the universe giving birth to itself? In chaotic inflation framework, quantum fluctuations trigger universes to come into existence from each other and start to inflate forever. Every branch gives rise to its own branches, transforming the entire structure into an endless fractal tree of universes. Yet, what is the origin of the very first universe, or the trunk? The first universe could potentially create a time loop, allowing it to loop back in time, grow up to be the trunk, and give birth to itself. The time loop initiated at the beginning enables the universe to become its own mother. Anything that follows the circular path in the time loop has a limited history without a definitive earliest event. If a virtual observer were to travel the time loop, he could return to his starting point. He could even revisit events from its own past. A prime example of this is how people used to say the Earth is either infinite to the past or finite with an edge. That's obviously wrong as the Earth's curvature comes into play. One can travel eastward indefinitely, eventually return to right where he started. Once something moves beyond a specific area outside the loop, it'll go towards the future, incapable of time travel through the loop ever again. This region of no return is called Cauchy horizon, a boundary or surface in space-time from where certain regions become causally disconnected. It's the region where the closed time-like curves are formed, and where the cycle of self-creation within the universe's perpetual loop begins. Beyond the Cauchy horizon marks the starting point of chaotic inflation. So this is a multiverse model with a beginning but no earliest event. Every region of space-time contains an event that happened before and served as its cause. But where is the beginning of this entire thing? The answer is the whole loop. The universe initiates with a closed time-like loop, but this occurrence is not bound to a specific moment in time. As an object journeys back in time progressively, it will eventually find itself within the loop, continuously circling around it. It's revisiting the same events in a loop rather than having an infinite past, just like how the Earth isn't infinite to the West. This absurd concept is also known as causal loop. Within the circular form of time, an event in the future influences the past, creating a loop without a clear beginning or end. A fascinating implication arising from this model is its inherent ability to address a big mystery in physics referred to as the arrow of time. Certain parts of Einstein's solutions are time symmetric, meaning things are time reversible, and there's no apparent reason for them to always move toward the future and not the past. Why does the arrow of time consistently point forward? In this multiverse model, beyond the Cauchy horizon where the chaotic inflation begins, if, let's say, a light particle is released, its path is towards the future, matching our everyday perception. But if it moves backwards in time and passes the Cauchy horizon, it would eventually end up in the initial time loop, where it would repeat the loop for infinity. This would lead to accumulating an infinite amount of energy, ultimately destroying the system. So why the flow of time is always towards the future and not the past? Because the only coherent solution for the geometry of this kind of multiverse is to establish an arrow of time directed towards the future rather than the past. Similar to how no one is permitted to journey back in time and cause a paradoxical situation, like the bizarre scenario of a time traveler traveling back in time and kill his own grandparent. The concept of a self-creating universe raises complex questions and paradoxes related to causality, time, and the nature of reality. This extends beyond our intuitive understanding and is expected to appear nonsensical at first glance. But Einstein's works suggest that time can manifest behaviors that are vastly different from what we commonly experience, especially when the curvature of space-time becomes remarkably large. So this multiverse has inherent mechanisms that explain its origin and development. A self-consistent system that its very nature allows it to generate and sustain itself. It undergoes an eternal cycle of creation, without the need for a definite starting point or an external cause. Its future influences its past, and the past influences its future, forming a continuous loop without any distinct beginning or ending. Perspectives on the nature of reality can appear extraordinarily bizarre, but the strangeness diminishes when in comparison to the fundamental question, why is there anything? Perhaps the question doesn't have an answer, not because it's profound, but rather because it's invalid. Because the question suggests that there ought to be a reason or cause behind existence. Maybe the concept of a reason why is relevant only to entities existing within reality, rather than to the very existence of reality itself. Everything has a beginning and an end, but existence itself might not. If the principles of cause and effect don't apply to the existence as a whole, then reality is not an effect, and it doesn't have a cause. It just is. The most straightforward response to the why existence could simply be, why not? Nothing is more straightforward and less complex compared to something. And yet, the default state is something instead of nothing, maybe because reality doesn't have a starting point or an end. Something has consistently been present, and the notion of nothing is not applicable. Absolute nothingness is incapable of giving rise to anything. Something and nothing are creation, reposition, destruction, recycle, and recreation of what already is. Maybe the very existence of the universe and its physical laws lie in a profound principle, one that selects this specific manifestation of things. The entirety of existence may not be an absolute requirement, yet it could still align with certain principles, like simplicity. Maybe reality stands as the most straightforward, efficient, and elegant one, handpicked by a guiding principle to come into existence from the vast expanse of all conceivable alternatives, and the enigmatic nature of this principle grants us the gift of existence. But even then, the question would remain, why would this principle have the capacity to give rise to reality? Why not a reality that lacks this principle? By probing deeper in physics, it becomes increasingly clear that the universe's existence is likely devoid of any underlying reason. Particles and energy can arise from fluctuations in the vacuum state or empty space, giving rise to the appearance of something from what was previously considered nothing. That nothing is what the universe is fundamentally made of. Something is just a strange version of nothing. Nothing in this context is the ultimate reality. The balanced nature, the flawlessness of nothing were destined to eventually end up in the emergence of two opposite uncertain somethings. The universe then unfolds and takes shape, materializing as matter, energy, the continuum of space-time, galaxies, stars, and planets. The existence itself apparently has no reason or purpose. It is entirely conceivable that existence needs no further explanation and simply exists. No matter how devoid of purpose and unsatisfying, it's plausible that reality just simply is, without any underlying reason or explanation. There may be no other coherent answer. Reality orchestrates its own symphony of existence. There could be two possibilities. Either nothingness or something else is eternal. The states of existence and total emptiness are the only logical alternatives. If eternal absence was the case, then nothing would exist for all eternity. But we are here, and we are aware of existence. Maybe in the distant past, absolute nothingness prevailed, and then reality came into being for no reason. It's been argued that for anything to come into existence, there has to be an inherently eternal something, and anything in existence can be linked back to that undeniable eternal entity, whether it takes the form of a principle, a brute fact, or a supreme being. But when and how could a choice or distinction between complete emptiness and containing something occur? If reality came into being at some point in the past, it must have emerged only after ensuring that no irrationality was involved in its existence. But this essential condition wasn't just a matter of being prior in time. Instead, it stood independently, unaffected by the actual existence of anything. We might expect the natural state to be non-existence, but why? Why the default should be a complete absence of anything? Just because in general nothingness is a conceivable concept, it doesn't necessarily justify our demand for an answer to why there is something rather than nothingness. The question is ultimately beyond our grasp, or it holds no inherent meaning to begin with. The concept of non-existence could just be an abstract notion belonging to our imagination. It remains beyond our ability to interact with, test, or even perceive nothingness. The eternal presence of reality could ensure that absolute nothingness can't simply be the case. Absolute nothingness could be truly impossible, and if it is, there could be reasons behind its impossibility. Maybe the very idea of nothingness is paradoxical and incoherent. Maybe the prospect of a reality devoid of existence itself, as believed to be a plausible alternative, is just a mirage and disqualifies as a truly viable proposition. There's the potential for anything in reality to cease and fade away. But could this transitory absence also have applied to reality itself? Could reality in its entirety find itself in a state of non-existence? Maybe the core reason for existence is in the absence of any coherent alternative. Perhaps the very nature of existence is an unavoidable force that demands the presence of some form of reality. The existence stands as an undeniable truth, grounded in an inherent necessity. The inherently paradoxical nature of nothingness could be seen as problematic, as it implies a void or absence that demands the presence of something to be absent from. The concept of nothing implies a lack of something, which implies the existence of something to be lacking. Therefore, the existence of true nothingness cannot be coherently defined. Maybe existence, by definition, must necessarily exist, and it cannot be otherwise. There might be a determining factor that rendered the world non-empty in its present form without any other variations. Every natural explanation may eventually reach a point where it cannot go any further and relies on fundamental, unexplained assumptions, but they could also extend infinitely into profound depths. Certain entities may exist independently, without being reliant on anything else for their origin and existence, like mathematical truths that exist independently of the physical world, a requirement for the mathematical multiverse to work. In contrast, maybe mathematical facts are not entities at all, but rather are simply true statements. They don't have any kind of existence independent of the minds that conceive them. They're simply a product of our thinking and reasoning, not discovered, but rather created by intelligent beings. Maybe if we remove everything physical, 2 + 2 = 4 would also be somehow removed from reality, until a minimum of 4 things somehow come into existence. Maybe reality has an inherent capacity for self-explanation and self-creation. Anything that its opposite violates the laws of logic is a logical necessity. Essentially, any scenario within the bounds of logical feasibility that can be imagined, like any alternate versions of our lives, each in a distinct universe, happens out of necessity. The laws governing the physical realm could be conceived as manifestations of pure logic that create universes. The abstract principles of nature have the potential to generate universes. Potential equals possibility, and possibility is necessary to exist. Anything imaginable is possible. Anything that's not prohibited must exist, an idea that resembles the mathematical multiverse. All possible mathematically formed realities have some kind of existence. Amongst different scientific hypotheses, the most favored option is the one that relies on the fewest assumptions. In contrast to the notion that there is only one universe, exceptionally fine-tuned for life, multiverse is a more straightforward and simpler explanation. If the universe originated through a physical mechanism, it could be absurd to think that this mechanism functioned only once or for a finite number of instances, whether in 20 or 20 trillion instances. The actual existence of all logically possible worlds, though it might appear incredibly complex, would in a sense be the most straightforward and least arbitrary option. The description is very simple. The reality is the sum of all logically possible worlds. No need to ask why this specific universe, why these particular physical laws, why these equations, or if this universe is unique, what prevents the emergence of other types of universes? If every logical possibility finds its way into existence, and if we entertain the notion of infinite separate regions in space-time or universes within a multiverse, then each conceivable possibility inevitably manifests in one of those universes, including every possible version of our lives. The mystery of existence in this worldview becomes more approachable. In the mind-bending realm of the multiverse, the line between boundless possibilities and concrete existence becomes blurry. The principle of simplicity could also increase the chances of God's existence. The simplicity of God's infiniteness could make belief in its existence simple, as describing infiniteness is easy. Where is God? Everywhere. Or, God is everything, so it's also everywhere. What is God capable of? Anything that is possible. Although in this context, the word God could be replaced by existence or reality. Maybe reality isn't a platform into which things emerge, but rather it's the container of the entirety of existence. Instead of conceiving reality as a static backdrop or separate container for individual existences, it can be also seen as the totality of everything, the very foundation that gives rise to and includes everything. This alternative perspective encourages thinking of reality not as a static space, but as a dynamic force that includes every aspect of existence, from the smallest particles to the grandest cosmic phenomena. So is there any hope of making any progress in understanding why reality exists? Many believe the question why is there something rather than nothing is so profound that it goes beyond the scope of scientific investigation. The nature of the question and its inherent complexities makes it impossible to obtain a definitive answer. Any scientific probe trying to address fundamental existential questions is unlikely to be successful, since it doesn't align with any observed phenomena or scientific information and lacks predictions that can be tested. Science primarily focuses on explaining the existence of contingent or dependent things, mostly in terms of how rather than why. Scientific discoveries usually raise as many questions as they answer. Every cosmological model encounters a boundary that marks the extent to which it cannot pass. If cosmic inflation doesn't extend infinitely into the past, what sets it in motion in the first place? During the emergence of universes from nothing through quantum tunneling, how are the physical laws already there? What could possibly explain the existence of the whole system of a universe traveling back in time and creating itself? Our ability to provide absolute and comprehensive explanations for these questions may always be limited. Whether a sequence of cause and effects has an origin or just exists, the question remains. Why does this specific chain of causes persist through all eternity and not any other sequence, or none at all? All these questions surpass the boundaries of any concept or idea currently within our grasp. From a purely scientific perspective, the question, why is there anything, is considered a meaningless pseudo-question. Only questions that can be tested through observation and experimentation stand a chance of obtaining an answer. Some hope that the most profound questions regarding existence are not outside the scope of science, and there is a possibility of gaining insights into all of them in the future. As of now, we have confidence that the physical laws predated the universe, and have many theories explaining the genesis of the universe itself. Regardless of how improbable it may seem, if our universe is the only existence, there could be something remarkable and profoundly unique about it that might explain its existence. If the notion that our universe is a random incident perfectly suited for us were true, it would demand an astronomical level of precision and accuracy in its configuration. In contrast, the multiverse hypothesis offers an infinite number of universes, each with different characteristics, and we happen to live in one that is suitable for our existence. The less reliance on assumptions makes the multiverse a simpler alternative. It would be improbable for a mechanism that creates universes to function only on a single occasion, because it would imply that it's not a natural process and the universe is a singular event. Conversely, the mechanism behind universe creation could be continuous, leading to the emergence of countless universes. Creation of universes are recurring phenomena that find their way into existence. Considering the vastness of the multiverse and the variations in physical laws, there may be countless universes that are hospitable to more diverse intelligent beings. If that's the case, then maybe there's no cosmic purpose behind our existence, but rather we're just a natural outcome of an immense and diverse multiverse. Reality has the potential to continuously manifest itself in all conceivable ways throughout eternity. Assuming existence is eternal, then every entity, every event, every outcome, everything has the potential to exist at some point. Every possibility will be realized. The very nature of reality cannot account for the existence of something rather than nothing, but maybe some abstract facts can. Like the fact that a blank can have a singular configuration while there are countless potential forms of existence, or the physical laws that rendered nothingness impossible. These facts were not dependent on any pre-existing entities and didn't require any explanation. The opposing view is that facts owe their origin to things that are already present. Without existing entities, there can be no facts. Only things that exist can produce them. If there's absolutely nothing, then addition or multiplication is meaningless. So what's the meaning behind all of this? For many, the notion of a universe without a divine creator can imply the absence of any ground cosmic purpose for human existence, implying that perhaps purpose and meaning are mere illusions. Finding meaning in the complexity of the universe can be challenging when everything can be explained by natural forces alone. An alternative perspective embraces nature as a source of boundless wonder and amazement. Instead of seeking from a transcendent creator, some find meaning in the very fabric of the universe itself, contemplating the elegance and sophistication of the cosmos. Humans in this worldview are not just some observers, but active participants in the cosmic story. The fact that we're made of stardust, that our bodies and minds are product of billions of years of cosmic evolution, and the understanding that our existence is not isolated from the universe, but an extraordinary element within it, can serve as a source of deep inspiration. The journey of life is deeply personal and philosophical. the human spirit will persist in its quest to uncover the profound mysteries that reside at the very core of existence. In a logical sense, the initial state should be nothing, and yet, against all odds, we find ourselves here. We don't know why, and most likely will forever be left in ambiguity. With each new revelation, we become increasingly aware of the vast expanse of what we have yet to understand. And it's hard to imagine how this ongoing pattern won't persist endlessly into the future. Even for an infinitely advanced civilization, a kind that has achieved the highest possible level of knowledge and technological advancement, the pursuit of an ultimate explanation will more likely remain a wondrous endeavor. Reality could have emerged not from a state of complete nothingness, but from something so abstract that it transcends all existing entities, evolved from a form of time that exists autonomously, without relying on anything external, emerging from an inherent necessity of actualizing every possibility, arising from the fact that there's only one conceivable path for non-existence and an infinite set of potentials to existence.